Welcome to week 6, lecture number 1. I am Dr. Sayyid. In this lecture, we will focus on the most important step of the design process of clock sequential circuits, which is essentially deriving a state diagram given a problem specification. And for this purpose, we will use sequence detection problems as design examples. So in previous lectures, we have already seen sequence detection problems in the context of non-overlapping specifications, but the focus of this lecture would be on overlapping specifications. And also we will see some more complex design problems where we have multiple sequence detection problems. So after going through this lecture, you should be able to independently derive state diagrams given a problem statement. Sequence detector is a sequential circuit which has an input, serial input and serial output. The output is normally in low state and it is only asserted when the desired sequence is detected at the input of the circuit. So we can essentially think of a sequence detector as an electronic combination lock, and whenever the correct key combination is keyed in, the door opens for a small period of time and then it goes back to its normal position. One of the important uses of a sequence detector circuit is in spacecraft to ground station communications, where it is used to detect binary sequences indicating the start or end of a data block. And similarly, it is also used to identify binary sequences in baseband digital communication, which actually indicate the start or ending of a particular message. So both these applications motivate the design of multiple sequence detection circuits. Suppose we are given a problem specification of a sequence detector circuit जिस पे अगर इनपुट सीक्वेंस 0110 at its input register हो तो then only the output should be asserted. So in order to come up with this state diagram, we should have to follow a number of important steps before we can come up with a state diagram. The first and foremost is we have to understand the problem statement correctly. So by looking at this problem statement, हम देख सकते हैं कि a circuit has a serial input and an output. तो हम block level diagram अपना इससे by looking at the problem statement we can come up with a block level diagram where the serial input let's say is x और हम y से denote करते हैं अपनी output को. Now the next question is how can we model the behavior of this circuit. So essentially we can model it using a finite state machine where we हम sample कर रहे हैं input bits पे और let's say जब भी हमारा कोई desired sequence input पे occur करता है let's say for example 0 1 then our circuit recognizes it with a particular state. So in order to further clarify this, let's see this timing diagram where we have a desired input sequence here, okay, and we are sampling it at particular clock edges. So for example at clock edge number 1 हमारा circuit, let's say before that it was in some state S0, ठीक है, and when the first bit of the desired sequence 0 occurs at a clock edge, this should be recognized or registered by a circuit by going into another state जो कि अब represent कर रही है कि 0 register हो चुका है input पे, which is the first bit of our desired sequence. वह second clock edge पे the second bit arrives, ठीक है, हमारी desired bit. So our state of the circuit should change to 0 1, ठीक है, which is registering that the first two bits of the desired sequence are already seen by the circuit. The third clock edge हम अपनी स्टेट चेंज करके 0 1 1 पे जा सकते हैं सर्किट की, एंड देन फाइनली at the fourth clock edge when the desired input जो कि x is low, then we can make our output high. So essentially we can model this problem using a finite state machine. But before that, we have to come to step number 2, which is asking the important questions about the patterns itself. So the first question would be कि जो हमारे पैटर्न्स हैं वो इंडिपेंडेंट और या फिर जिनको हम नॉन ओवरलैपिंग पैटर्न्स भी कहते हैं वो इंडिपेंडेंट पैटर्न्स हैं या फिर ओवरलैपिंग और डिपेंडेंट पैटर्न्स भी हो सकते हैं. फॉर एग्जांपल इन केस ऑफ नॉन ओवरलैपिंग पैटर्न्स टिपिकल इनपुट आउटपुट सीक्वेंस हमने यहाँ पे इट्स गिवन हियर. इधर अगर हम देखें तो this is our desired sequence 0110, but of course हम ये भी देख सकते हैं कि if we use the last bit of the detected sequence as the first bit of the next sequence तो ये भी हमारा जो desired sequence है 0110 वो बन जाता है. But because we are having non-overlapping specification, so only independent patterns are allowed, so we cannot use this 0 here. ठीक है, तो इसका मतलब है हमारी जो आउटपुट है वो सिर्फ इंडिपेंडेंट पैटर्न्स के लिए ही हाई होगी. ओके, so this pattern although it's there but in non-overlapping specification we cannot consider it and make our output high. In contrast, overlapping specification में basically we can use the last bit of the detected sequence as the first bit of the next potential sequence. तो यहाँ पे अगर हम इस पर्टिकुलर इनपुट आउटपुट एग्जाम्पल को देखें तो ऑफ कोर्स वी कैन अप्रिशिएट कि हमारी आउटपुट पहले इस डिटेक्टेड सीक्वेंस के लिए हाई होगी एंड देन जो ओवरलैपिंग सीक्वेंस है 0110 इधर भी हमारी सर्किट की आउटपुट हाई होनी चाहिए. सो वी कैन कंपेयर एंड कंट्रास्ट. देयर आर टू पर्टिकुलर ओकेजन्स जहाँ पे हमारी ओवरलैपिंग के केस में आउटपुट हाई हुई है एज कंपेयर टू नॉन ओवरलैपिंग केस जहाँ पे सिर्फ देयर इज ओनली वन इंस्टेंस जहाँ पे हमारी आउटपुट हाई हो रही है. इसी तरह एक और एग्जांपल देखते हैं वे वी हैव मल्टीपल बिट ओवरलैप. फॉर एग्जांपल कंसिडर दिस सीक्वेंस वी आर आफ्टर 11011. सो हमारा डिजायर्ड पैटर्न ये है. तो इन दिस पर्टिकुलर केस एक तो फर्स्ट पैटर्न ऑफ कोर्स वी कैन आइडेंटिफाई एज दिस एंड बिकॉज ओवरलैपिंग पैटर्न्स आर अलाउड तो हम ये जो लास्ट टू बिट्स हैं ऑफ दिस सीक्वेंस वी कैन use them as the first two bits of the next sequence. तो essentially हमारी आउटपुट हाई होगी फर्स्ट सीक्वेंस की डिटेक्शन पे और सेकंड सीक्वेंस हमारा यहाँ पे डिटेक्ट हो गया सो आउटपुट विल बी हाई फॉर दिस एज वेल. तो ये डिफरेंस है बिटवीन नॉन ओवरलैपिंग एंड ओवरलैपिंग specifications which should be considered, and it's important question to ask. We should clarify all the questions, all such questions before we come up with the state diagram. Otherwise हमारी जो functionality है वो required specifications के मुताबिक नहीं होगी. The second important question is whether to come up with a Mealy type finite state machine or a Moore type finite state machine. So in previous lectures काफ़ी डिटेल में हमने कंपेयर एंड कंट्रास्ट किया है मीले एंड मूर टाइप एफएसएम्स को. बट इन द कॉन्टेक्स्ट ऑफ सीक्वेंस डिटेक्टर सर्किट्स व्हाट वी कैन से हियर इज इफ वी आर डिटेक्टिंग एन एन बिट सीक्वेंस तो जो मीले की स्टेट्स हैं वो एन स्टेट्स में हम एक एन बिट सीक्वेंस को डिटेक्ट कर सकते हैं इफ वी फॉलो अ मीले टाइप एफएसएम. और फॉर अ मूर टाइप एफएसएम we'll always it will always take n plus 1 states, which is more states as compared to the Mealy type FSM in order to detect the same sequence. तो दिस इज अनदर इम्पॉर्टेंट डिज़ाइन चॉइस जो कि हमें यहाँ पे लेनी पड़ती है when we are designing a particular circuit, and it's mostly application dependent, but sometimes it's also a matter of choice, और ये डिजाइनर की चॉइस पे भी होता है कभी कभार कि whether we have to come up with Mealy type circuits or Moore type circuits. So after we clear all the particular questions, जब हम उस पे क्लियर हो जाएं, then we can of course go and draw the or derive the finite state machine for our particular problem. So up in next part of the lecture we will see both Mealy and Moore type finite state machines for the pattern 0110, also for 11011, and we will also see sequence detection examples where multiple sequences are to be detected. Now that we have all the design requirements, let us see a Mealy type state diagram for our desired sequence 0110. Let S naught be our initial state or reset state, and of course it's a Mealy type state diagram, so we'll be showing input and output over the arcs like this. So if input x is 0 और हम S naught के ऊपर हैं, so that's the first bit of our desired sequence, so we'll present it with state S1, ठीक है, and of course S1 is showing us that हमारे पास first 0 register हो गया at the input, ठीक है, but if 1 arrives, if we are at S naught और x जो है वो 1 हो जाता है, as long as 1 arrives तो हम इसी reset state पे रहेंगे and will keep the output of the circuit low as well, because 1 is not part of our desired sequence. Coming on to S1, the input x is 0, then we could treat it as the first bit of our desired sequence और हम इसी state पे रहेंगे इस case में भी, and we'll keep our output low. But if a 1 arrives, x is 1, then we need to create another state S2. S2 is actually telling us that the first two bits of our desired sequence have been registered. So S2 के ऊपर भी if x is 0, then 010 is of course not part of our desired sequence, but we can use the last bit 0 as the potential first bit जो कि S1 शो कर रही है हमारी स्टेट. We will go to S1 if the input comes out to be 0, output भी हम अपनी 0 ही रखेंगे because the desired sequence has not been, अभी हमें पूरा sequence नहीं receive हुआ, has not been registered yet. S2 के ऊपर if a 1 arrives, of course this is part of our desired sequence. I will keep our output low and we'll go to next state S3. S3 state जो है that is actually representing कि 011 has already been registered, but of course the output is our output still low because the desired sequence has not been achieved yet. S3 के ऊपर अगर 0 आ जाता है then of course हमारा desired sequence receive हो जाएगा, तो output तो हमें high करनी है, but of course in case of the next state we can go, because we are using overlapping, and we can use this 0 as the potential first bit of our next sequence. We'll make our output high if a 0 is received. The second scenario is we are on S3 and a 1 arrives, so 0 1 1 1 is not part of our desired sequence. So in this particular case what we'll have to do is we'll have to go to the reset state and start looking for the next desired sequence, ठीक है. तो अगर input 1 आ जाए on S3, output should be low of the circuit should be low because the desired sequence has not been fully achieved, तो हम S0 पे चले जाएंगे keeping our output low. So this is the complete हमारी Mealy type state diagram for our desired sequence 0110. Of course हमने इसमें overlapping consider की है. अब हम देखते हैं कि Moore type अगर हमें स्टेट डायग्राम ड्रॉ करनी हो फॉर द सेम स्पेसिफिकेशन, सेम सेट ऑफ डिजाइन रिक्वायरमेंट्स, तो हम कैसे कर सकते हैं. तो लेट्स से हमारी इनिशियल स्टेट इज एस नॉट एंड ऑफ कोर्स Moore में हम आउटपुट जो है वी शो इट inside the state, so our output is 0 in our initial or reset state. So of course any number of ones arrives, they are of no use to us, तो हम reset state पे ही रहेंगे. But if x is 0 on S0, तो हम उसको represent करेंगे with a new state course we can represent it with S1 output जहाँ पे हमारी फिर भी of course low रहेगी. Now so S1 is once again representing that the first zero of the desired sequence has been registered. S1 के ऊपर there we have two choices, either the input x could be 0 or it could be 1. If 0 occurs on input x, will stay at S1 considering it as the first bit of the desired sequence. But if a 1 occurs, of course that's part of our desired sequence, तो हम उसको x state S2 से show कर देते हैं. Output हमारी still 0 ही रहेगी, and S2 is once again telling us that the first two bits have been remembered. अब S2 के ऊपर if a 0 occurs, then just like we did it in the melee type state diagram, basically because 0 1 0 is not part of our desired sequence, तो हमें S1 पे जाना पड़ेगा considering this as the first zero of our desired sequence. अगर 1 occur करता है तो well and good, we go to another state S3. We'll keep our output low because the desired sequence has not been fully received yet. तो S3 के ऊपर अगर x is 0, then of course हमारा desired sequence achieve हो जाएगा, and because this is mode type state diagram, हमें output high करने के लिए we'll have to go create another state which we call S4 let's say, और इधर हम अपनी output को high कर सकते हैं. ठीक है, तो this state is telling us that the desired sequence has been received when on S3 a 0 is received at the input. But अगर S3 पे if the input x is high, then of course हमारा sequence जो है वो बन जाएगा 0 1 1 1, which is not part of our desired sequence and will break our sequence, और इस केस पे हमें जाना पड़ेगा reset state के ऊपर if a 1 arrives at S3. ठीक है, now S4 is a state जो कि हमें बता रही है कि the desired sequence. So S3 is representing 0 1 1 and S4 हमारे पास represent कर रही है कि desired sequence has been achieved, completely achieved. तो output हमारी circuit की high हो गई. Now at S4 if 0 if the input is low, तो of course we can consider it as the first 0 of the next sequence, and in that particular case we'll go to S1. ठीक है, और अगर S4 पे हम हैं और 1 arrive हो जाता है, then of course we can use the last two bits, the last bit of the desired of the detected sequence and the 1, और हम जा सकते हैं, this is represented 0 1 is represented by S2, so we'll go to S2 if a 1 arrives at S4. Okay, so this is our mode type state diagram or finite state machine for the sequence 0 1 1 0. Moving on to our next example, जो कि हम एक design example ली है, which is a sequence 1 1 0 1 1. So it's a similar problem of a sequence detection, and overlapping sequences should also be considered. तो हम इसके लिए melee type state diagram सबसे पहले देखते हैं. This is a more complex problem than what we have experienced before, जो भी हमने पहले देखा है. Starting with initial state S0, if 0 arrives at the input, of course at S0 it will be of no use. तो अगर 0 arrive हो रहे हैं तो हम output को low ही रखेंगे and we'll stay at S0, the initial reset state. But of course अगर हमारे पास 1 arrive होता है input पे x is high, then we'll go to next state S1, और S1 हमें of course बता रहा है कि 1 the first one has been registered at the S1 के ऊपर. If we are on S1 and 0 arrives, then of course we'll have to go back to the reset state because 1 0 is not part of our desired sequence and our output will be low. But of course अगर 1 arrive होता है at S1, then we'll have to create a new state S2 in order to show that the first two ones of our desired sequence have been received. Okay, now at S2 if a 0 arrives, then this is part of our desired sequence, और हम उस केस में of course चले जाएंगे on to our next state S3, which is representing that 1 1 0 has been remembered or registered at the input. लेकिन अगर S2 पे if a 1 comes, then of course we can consider this as the second one, the first one being this and the second one in the desired sequence. So we'll stay at S2 and we'll keep our output low, which is actually saying that two ones have been arrived. So any number of ones अगर आते रहे, we'll only consider the last two. So this arc is actually representing this information. तो S3 के ऊपर अब हम हैं और जीरो अकर कर जाता है, देन 1100 ये हमारा जो डिजायर्ड सीक्वेंस है उसको डिस्टर्ब कर देगा एंड विल हैव टू गो बैक टू द इनिशियल स्टेट रीसेट स्टेट अगर जीरो आ जाता है S3 पे एज इनपुट, बिकॉज आवर सीक्वेंस विल बी, वो ब्रेक हो जाएगा सीक्वेंस. बट इफ वी आर ऑन S3 एंड the input is high, then of course you should create a new state S4. Okay, and S4 is telling us that 1101, the first 4 bits of the 5-bit sequence are registered or remembered. S4 पे हम, तो इसका ये मतलब है कि we have already seen 1101. Now only we are left with the 1 bit of the desired sequence. S4 के ऊपर अगर input 0 हो जाए तो 11010 once again हमारा sequence यहाँ पे break हो जाएगा and we'll have no choice but to go to the reset state if a 0 arrives, and of course we'll keep our output low. But if we are on S4 and the input becomes high, then हमारा desired sequence achieve हो जाएगा 11011 और output हमने high करनी है, but we have to decide which state to go to. So 1011 अब 1 input पे arrive हुआ है, तो of course we are using overlapping, so you can use the last two bits of the detective sequence as the potential first two bits of the next sequence. और ये हमारी state show कर रही है S2, तो of course we'll go to S2 in this particular scenario अगर S4 के ऊपर 1 arrive हो जाए, and we'll also make our output high here. ठीक है. So this is a Mealy type finite state machine for our desired sequence 11011. Let's go to our final problem, sequence detection problem that we want to learn in this particular lecture is a multiple sequence detection. तो यहाँ पे आप देख रहे हैं कि the statement starts with design a sequence detector whose output is asserted whenever either of the input sequences 1001 or 010 has been observed at its input. So basically what we can, and overlapping sequences should also be considered. तो अगर हम देखें तो हमारा जो sequence detector है उसकी इनपुट एंड आउटपुट आर जस्ट सिमिलर, जो इस तरह हमने पहले भी देखा है. ठीक है, सो देयर इज वन इनपुट x, serial input x and a serial output y. Of course it's a sequential circuit, your clock. But what's different is कि serial stream के अंदर x पे अब जब भी 1101 या फिर 010 अकर हो, दोनों में से कोई भी अकर हो, तो आउटपुट शुड गो हाई. इसकी टिपिकल सीक्वेंस, इनपुट सीक्वेंस हम देख लेते हैं. Define a input x. Let's say the x is input is like this. So our output will be, first of all we can see that we can detect 010 here. Okay, and there is an overlapping pattern of 1001 here, and finally there is one other overlapping pattern of 010. So our output should detect all these three overlapping patterns. So our output will be low for the first 5 bits, and of course we can appreciate यहाँ पे भी हमारी output low होगी, but it will get high for this particular 010 sequence. उसके बाद will also be high for the 1001 sequence, overlapping sequence, and it will be high because there is this 010 sequence, and it will be low for the rest of the inputs. So this is a typical example. ठीक है, typical input example एंड ऑफ कोर्स इसमें काफ़ी सारे कॉम्बिनेशंस, इनफाइनाइट पॉसिबल कॉम्बिनेशंस हो सकते हैं जिस हिसाब से ये सीक्वेंसेस अकर करें, मल्टीपल सीक्वेंसेस. So let's, once we have defined, हमने थोड़ा सा प्रॉब्लम को समझ लिया है, we understood the problem and कुछ specifications भी देख ली हैं. We want overlapping patterns to be detected और multiple sequences हैं. So let's just see how a Mealy type state diagram हम कैसे इसके लिए बना सकते हैं. We'll start with an initial state. Let's say we call it S naught. Okay, and what we'll do here is we can start with just the first pattern. Let's say 0 1 0. Okay, so when 0 occurs on S naught, we keep the output low and go on to another state S1, जो कि हमें बता रही है the first 0 of the second sequence has been seen on the input. उसके बाद of course अभी हम इसकी दूसरा aspect नहीं देख रहे when we are on S0 and the input is 1. First of all we like to complete on this path. S1 के ऊपर अगर input 0 आ जाए तो of course what we'll do is हम इसी state S1 पे ही रहेंगे और उस जितने भी zeros आते जाएंगे उनको consider करते रहेंगे first zero of the one of the sequences. उसके बाद if we receive a 1 here, input 1 हो जाए तो of course this is हमारा 0 1 input pattern बन जाएगा which we can denote with another state S2. 0 1 has been received on the input. इसके बाद of course अगर S2 के ऊपर of course there could be two possibilities, but before that let's just go on to the other path और हम देखते हैं कि S0 पे अगर 1 अकर करे तो that's the first bit of our 1001 sequence. Output हम low रखेंगे but we'll show that the first one has been received of the 1001 sequence. ठीक है. Sorry, we denote it by S3. Okay, because we already used S2. तो S3 state पे अब हम हैं और if the input comes out to be 0 then this is part of our desired sequence 1001. तो हम एक और स्टेट क्रिएट कर लेंगे S4 और उसके ऊपर चले जाएंगे. But if we are on S3 and a 1 occurs, of course we can consider it as the starting one of the desired sequence और आउटपुट को हम लो रखेंगे और S3 पे ही रहेंगे on that particular case. Now S4 में before considering the possibilities for S4, let us go to S2 and try to complete this 0 1 0 sequence. तो 0 1 S2 पे अगर 0 occur हो जाता है तो that will complete our desired sequence 0 1 0, one of the desired sequences जिसमें हमने आउटपुट अपनी हाई करनी है. बट व्हाट शुड बी आवर नेक्स्ट स्टेट? तो जैसे हम देख सकते हैं कि 0 1 0, the last two bits of 0 1 0 are actually the first two bits of the other sequence which are denoted by this path here. Okay, so this path is denoting 1 0, so S4 is denoting 1 0. तो इसका मतलब है कि हम S2 से what we can do is if a 0 occurs on S2 we'll make our output high because 0 1 0 pattern has been detected and we'll go to S4 which is denoting 1 0. Okay, and this is 1 0 over here. Okay, उसके बाद so S2 is complete. S2 पे sorry अगर 1 occur हो जाता है तो फिर in that particular case we can say that this is the first potential first bit of the 1001 sequence और वो हमने S3 से represent किया हुआ है तो we'll go to S3 in that particular case if a 1 occurs on, but we'll keep our output low of course. S2 पे अगर 1 occur हो जाए. ठीक है. Now that we have completed दिस पर्टिकुलर पाथ, ठीक है, 010 वाला पाथ हमने कंप्लीट कर लिया, तो वी कैन फोकस ऑन द 1001 पाथ। अब हम S4 के ऊपर है, ठीक है। S4 पे आइदर वी कैन हैव अ 0 और अ 1। अगर 0 अगर हो जाता है तो दिस इज पार्ट ऑफ अ 1001 पैटर्न, तो दिस विल बी 100। आउटपुट तो स्टिल 0 रहेगी, बट विल go on to another state S5 which is showing कि 100 has been received, ठीक है। बट if we are on S4 और 1 अगर हो जाता है, that this means 101 अब हमारा सीक्वेंस बन गया है। तो 101 is not part of our first sequence, but the last two bits जो 01 है वो हम स्टेट S2 से रिप्रेजेंट कर रहे हैं। तो इन दैट पर्टिकुलर केस वी कैन गो टू, अगर S4 पे 1 अगर हो जाए तो हम 01 कंसिडर करके आउटपुट अपनी लो ही रखेंगे, बट वी कैन गो टू S2। Okay, now we are on S5 and let's say a 0 occurs. Okay, S5 1000 is not part of any of these sequences, but we can use this last 0 which is represented by state S1। तो हम इस केस में फिर क्या करेंगे, we'll go to the state S1 if a 0 occurs on S5, and of course desired sequence तो दोनों में से कोई भी अचीव नहीं हुआ तो our output will be 0। but if we are on S5 and a 1 occurs, तो 1001 जो हमारा desired sequence है वो अचीव हो जाएगा, and we'll have to make our output high 1001। and what should be our next state, तो आप जिस तरह देख रहे हैं कि last two bits are the represented by S2, तो हम S5 से इस केस में फिर S2 पे मूव कर जाएंगे when 1 occurs, which is also makes our 1001 pattern complete, तो हम अपनी आउटपुट भी हाई कर लेंगे and we go to S2। So this is the complete state diagram to detect multiple sequences, Mealy type state diagram to detect 1001 or 010, जो भी either input पे आएगा in any order that should be detected, और output हमारे circuit की high हो जानी चाहिए। So in case of Moore type state diagram, everything until this particular state, यहाँ तक ये जो भी हमने state show की हुई है, that this would be similar, but of course now from S3 we cannot go to S4 if a 0 arrives, because we have to make our output high। इस तरह हमें एक state चाहिए होगी यहाँ पे भी S5 के लिए। So this is once again another homework for you to complete this state diagram। This is not complete, we need to detect both the sequences 010 now and also 1001। So finally, just a brief review of what we have covered in this lecture। So हमने functionality देखी है of a sequence detector in detail, और formal specifications कैसे हम derive करते हैं from design requirements और problem statement in high level language। फिर हमने state diagrams देखे for sequence detection problem with the overlapping specification, और multiple sequence detection problem भी हमने एक consider किया है इस lecture में। Of course, as we discussed earlier as well, in the next lecture हम rest of the design process को दोबारा focus करेंगे। This was only the first step which is deriving the state diagram, then of course we have other steps, और उसमें हमारा focus होगा synthesis using JK and T type flip flop।